Okay, so now we will have example on getting the derivative of certain functions. Okay, so we have here the first example. So find the derivative with respect to x, the function of 2 minus 3x squared. Okay, so we just have our solution here. Okay, so we have our function. So maybe we just have our function as a function of x. F of x is equal to square root of 2 minus 3x squared. We could rewrite this one as an exponential function rather than a radical. So we have 2 minus 3x squared raised to the power of 1/2. Okay, now we could analyze this one. We will use the derivative of an exponential function, this one. Okay, so we'll use that one. So that will be the derivative of u to the n. Just have that one, derivative of u to the n in terms of x is equal to n, then u to the n minus 1. Of course, never forget that you must have also du, the derivative of your function itself. Okay, so our function is this one. So if we are going to follow the formula, so our n, so we now have our f prime of x. Okay, so our n is this one, 1/2. Then we will copy our u, which is this one. This is our u, 2 minus 3x squared raised to the power of 1/2. That is our n, minus 1. And now the derivative of our u. So the derivative of our u, the derivative of this one is 0 minus this one is 6x. Okay, so we are going to simplify. So we could neglect this one because that is 0. We have 1/2 times negative 6x times 2 minus 3x squared negative 1/2. So we will now have this one is 1/2 times negative 6. So we will have negative 3x. Then we could put this one as our denominator so that we will have a positive exponent. 2 minus 3. Okay, so 3x squared raised to the power of 1/2, or we could write that this one as a radical, our denominator as a radical, as square root of 2 minus 3x squared. And this will now be our derivative of the function. Okay? So that is how we are going to get the derivative of a function. Okay, next we will try to have another example if we could have. Okay, so we have this one. So find the derivative or the y prime if y is equal to arc sine cosine x. Okay, so we have the solution. So we will try to find y prime. Our y is arc cosine, so we could write that one as sine cosine x. Okay, so let's just we will try to first see what is the formula for the derivative of this one. So that is inverse trigonometric. So sine. So we have this one. Okay. So the derivative of sine, no, not sine, but arc sine x, or inverse trigonometry, inverse sine x in terms of x is equal to u. So let's check if that is u. Oh no, that is only equal to 1. Okay. So this is just 1. I believe the u is during the tangent. Okay, 1 over square root of 1 minus u squared. Okay, u squared. Then du, or the derivative of u itself. Okay, so we will use this formula. Okay, so our y prime is equal to, so our u here is equal to cosine x. Okay, so we have 1 over square root of 1 minus, so u, so that is cosine x squared. Then we will multiply the derivative of our u, which is cosine x in terms of x. So we will now have 1 over square root of 1 minus cosine squared x. So the derivative of cosine is negative sine, so negative sine x. This is multiply. Then we will have the trigonometric identity of this one, so that will be equal to square root of sine squared x, so that is the Pythagorean identity, negative sine x. So this will be equal to negative sine x over, so the square root of that one is just sine x, so we could cancel our sine x, and we will end up with, just write it here, negative 1. And this is now our answer. Okay, so of course in this problem you must have your knowledge also in trigonometric identities. Okay, so that will be all for this video. I hope you learned something from this video, and as always, keep on studying.